Hello everyone, I welcome you in physics classes. Dear students, in my last lecture I taught you about photoelectric effect, as well as we have discussed a very important experimental setup for this photoelectric effect, and we have deduced one very important term called as stopping potential. Students, stopping potential means the negative potential at which your photoelectric current becomes equal to 0. And after that, now our next topic is Einstein's photoelectric equation. Dear students, Einstein, he was a very famous scientist, as you know. So he has given this photoelectric equation, means he has also discussed the photoelectric effect, and whatever equation he has given, that is called as equation of Einstein's photoelectric equation. And with the help of that equation, he has concluded, he has deduced all 4 laws of photoelectric emission. That's why our topic is Einstein's photoelectric equation, but the question is asked in exam in this form, that derive the laws of photoelectric emission from Einstein's photoelectric equation. So let us proceed, students. According to Einstein, what Einstein says, that in photoelectric effect, whenever light falls on the metal surface, light means photons. So those photons are interacted with electron. Those photons will interact with electron, and photon is completely absorbed by electron. Photon will fall on the metal surface, and in metal what is there? Electrons. Those electrons will completely absorb that photon. Okay, and obviously when electron is absorbing that photon, its energy will get increased and electron gets ejected. स्टूडेंट्स, वंस अगेन आई एम टेलिंग यू कि जब भी आपके फोटोन्स मेटल सरफेस पे फॉल करेंगे तो मेटल के जो इलेक्ट्रॉन हैं वो फोटोन को क्या कर लेंगे? अब्जॉर्व कर लेंगे. और जब भी इलेक्ट्रॉन फोटोन को अब्जॉर्व करेगा, उसकी काइनेटिक एनर्जी क्या होगा? इंक्रीज हो जाएगी. जब भी उसकी काइनेटिक एनर्जी इंक्रीज होगी, इट विल गेट्स इजेक्टेड, ये बाहर आ जाएगा. ओके, सो what is the maximum energy of electron? This equation is very important. Maximum kinetic energy of electron is equal to energy of photon. That is okay, but minus work function, because full kinetic energy will not be of energy of photon, but some energy will lost as a work function. That's why energy of photon minus work function. So kinetic energy expression, you know, half mv square equal to energy of photon we have studied in our last lecture, h nu. Nu is frequency, h is Planck's constant, minus w. W means work function. Students, work function means how much work it is doing in taking out that electron. Okay, so means this work function totally depends upon threshold frequency. Let me tell you once again, let me remind you that threshold frequency is the minimum frequency required to eject electron from the metal surface. कम से कम जितनी frequency चाहिए electron को eject करने के लिए. So that is denoted by nu naught. Okay, nu के नीचे 0 है, we read it as nu naught. So W is equal to h nu naught. Okay, so putting back in equation number 1, half mv square is equal to h nu minus h nu naught. You can see h and h is common, that means Planck's constant is common. So take Planck's constant outside, you will get nu minus nu naught. So this equation, that half mv square is equal to h nu minus nu naught, is called as Einstein's photoelectric equation. Okay, I hope that each and every term in Einstein equation is clear to you. So let us conclude that what is the conclusion of this Einstein's photoelectric equation. Students, from this equation it is clear that h nu is greater than h nu naught, because kinetic energy is not negative, it is positive, and for Positive kinetic energy, obviously first term should be greater, second term should be smaller, means at nu should be greater than at nu naught. So that means for emission of electron, your at nu means frequency should be greater than threshold frequency. And if you remember, this is one of the law of photoelectric emission. Let us proceed towards the second, maximum kinetic energy. Students, you can see here that kinetic energy is in numerator and nu is also in numerator. That means both are directly related to each other. That's why it is written that maximum kinetic energy is directly proportional to frequency. Okay, means the kinetic energy with which electron will get ejected, it depends upon frequency. It does not depend upon intensity. Okay, so this is also one law in photoelectric emission. Third, according to Einstein, electron absorb photon. इलेक्ट्रॉन फोटोन को क्या करता है? एब्जॉर्व करता है. तो मतलब जितना ज़्यादा फोटोन्स होंगे उतने ज़्यादा इलेक्ट्रॉन्स इजेक्ट होंगे. Am I clear to you? जितने ज़्यादा फोटोन्स होंगे उतने ज़्यादा इलेक्ट्रॉन्स इजेक्ट होंगे, उतना ज़्यादा फोटो इलेक्ट्रिक करंट होगा. दैट मीन्स मोर इज़ द इंटेंसिटी ऑफ लाइट. इंटेंसिटी ऑफ लाइट मीन्स जितनी ज़्यादा लाइट होगी उतने ज़्यादा फोटोन होंगे. सो मोर इज़ द इंटेंसिटी ऑफ लाइट, मोर विल बी फोटो इलेक्ट्रिक करंट. Okay, and last point is, as soon as photon is absorbed by electron, emission will take place frequently. Obviously जैसे ही आपका इलेक्ट्रॉन फोटोन को एब्जॉर्व करेगा, एमिशन होना स्टार्ट हो जाएगा. सो दीज 4 laws, if you remember, these are the laws of photoelectric emission, and these laws we have concluded by using photoelectric equation given by Einstein. So students, that's why this question is asked in exam in this form, that derive the laws of photoelectric emission from Einstein's photoelectric equation. I hope the terms are clear to you, and this question is very important from examination point of view, because every time it is coming in exam with the same form and for 3 marks. So I hope it is clear to you. For any query, you are free to ask me. This is enough for today, students. Thank you. Have a good day.